On to the heap sort. So today we're gonna demonstrate about what heap sort is. That it's a comparison-based sorting algorithm. So usually comparing two elements, and a heap just means an untidy, clutter array of things or stuff. So we're gonna go through that. Another tidbits on it. What does it say? Most of the time, it's a although most of the time, in practice, it's slower than a well-implemented quicksort. Quicksort kind of has the edge. It's okay, heap sort, but it's kind of its plus is it has an advantage of it's the best at sucking the words. So it has a favorable worst case runtime of big O of n log n, which is decent, I guess. I'm not too versed in algorithm analysis quite yet, but anyways, so on to me figuring this out. So what we have here is you have your array of elements, which are ints, and then you have a binary tree here of the elements too, and how they match or correspond is this is the first element, so 88 or 88 zeros placed first, second, third, fourth, fifth, sixth, seventh, and so on. So it's like reading a paragraph of the order of the elements in the array. So what you do is the first one would be this, but then so this is just a jumbled up, unorganized array, and what we're going to do is heapify it first. So pretty much what that means is we're going to make sure that every child node of every parent is its value is less than its parent. So that's what all the heapify does. So first step is to heapify this array. Maybe this. And so as you can see, every child is less than its parent. 42 is less than 83, 6 is less than 42, 72 is less than 85, so on and so forth. So if you do that, your first position will be the greatest. So what you want to do is you can put that at the end of the array. So as you can see, now we have that. So this is the last place, so we can put that in the last one. Now what I want to do is we reheapify it, so we make sure that we follow the rules of the all the childs are less than the parents. So what we do is flip-flop this 83 with the 60, and that should work. Oh, that works too. Wait, does it do the bigger one? Apparently every time. Let's see. So that'll go 85. So now this should go to 83, 48, yeah, then 57. And then you put it down there. And then 6 should go to 73. 6, these two should flip-flop. And then these two should flip-flop. Alright, so I learned something there. That when you heapify, you pick the bigger of the two child nodes. So as you can see, 6, instead of going to 57, it went to the larger one of 70, 73, 57. So I went there. And those are kind of steps, and you just kind of keep on pushing them until you get to the end. So you just slowly but surely clean up your tree. So, alright, so going from here, we swapped it. So actually 60, these two would swap there. Yep. So now, since the heapify is complete, we can push 72 to 42 and then pop, well not pop, oh would it be pop? Yeah, 72 to this position then. So next what will happen is these two will flip-flop, and then we cement it, right? And then see, now it's cemented. Now we heapify and all over again. So this would go 42 would go to 60, and then that would go 48 would go there. So here goes 42 to 60, and then 48 to 42. Boom. So yeah, that's just the basics of a heap sort, and you just keep on doing it. Recurse it until you get to your case where 6 is the lowest, I would suppose. And kaboom! And that's how you sort an array of integers with heap sort. Baller!